On this sleep study, there are 15 channels being used. The top 2 channels are your eyes. One is your right eye and the other is your left eye. Notice your eye montage settings. It has R-EOG for the right eye and L-EOG for the left eye. Depending on your facility is going to determine how they abbreviate their eyes. Where I worked, we used E1 and E2. It all depends on where you go as to what they're going to use for their eye leads. It is important to know that your electrode on your right eye is 1 centimeter out from the outer canthus and 1 centimeter up. And this channel is taking that electrode and it's measuring the electrical activity between that and the M1 electrode, because M1 is our reference electrode on this study. So for the left eye, although we don't see it, it's taking the left eye electrode and referencing it also to M1 on this study. And I know that because those are the reference electrodes used on my F4 channel, channel 3, channel 4, and channel 5. So on channel 3, we're taking the right frontal lobe and it's being referenced to the mastoid 1 channel, or behind the right or left ear. On channel 4, we're taking the right central lobe electrode and we're referencing it again to the mastoid 1, or the left behind the left ear. And in channel 5, we're taking the right occipital lobe and we're referencing it to M1, which is just behind the left ear. So this is what's called a referential montage. All of the electrodes that we're trying to gather data from are being referenced to a similar electrode. Some other channels then as we go down the screen. Channel 6 is your chin EMG. Now that is an EMG because it's a muscle that we're looking at, not a brain activity. So EEG stands for electroencephalograph, meaning the electrical activity is coming from the brain. Channel 6, the chin, is an EMG, referring to it coming from a muscle or a myelogram. Channel 7 is our EKG, an electrocardiogram. Our right leg is next on channel 8 and the left leg is on channel 9. Both of those are again EMGs because it's muscle. Channel 10 is a snore mic. Not all facilities use snore mics. Channel 11 is a thermistor, so that's measuring the change in heat at the nose and mouth to monitor airflow. Channel 12 is a pressure transducer, and this is monitoring airflow at the nose and mouth with a nasal pressure transducer. Channel 13 is the chest belt or the thoracic belt, and channel 14 is the abdominal belt. Channel 15 is your SpO2 being monitored, and you see this patient's SpO2 starts at 94 and then drops down to 93%, and we want to keep our patient above 90% most of the time, although in sleep we don't have a lot of control over that. Let's go on to our next slide. Okay, so I want to explain a little bit about our montage and which are our settings. So I've taken a little snippet of the previous screen that we just had, and it shows the right eye channel, the left eye channel, the frontal lobe channel, the central lobe channel, and so on. So let's start with channel 1. Channel 1 is taking your right eye electrode, and I've put a picture on here for you to the right showing that the right eye electrode is located 1 centimeter out and 1 centimeter up from the right eye. Now in the picture of the head with the electrode, they're using the reference electrode of M2. I'm sorry about that, I didn't have one showing M1, but just so you know, that's what it would be looking like. So it's taking the data from the right eye and it's referencing it to the mastoid reference electrode, and it's using the data from the right eye that's different than the data being gathered at the M1 electrode. And we're going to look more at that. So if you feel confused by that, we're going to look more at it here in a little bit. Next is your left eye. That's 1 centimeter out and 1 centimeter below the left eye. And again, that would then be set up on your montage, so it's going to the reference of your mastoid 1, which in this picture I know it's showing mastoid 2. But next we have F4, so locate F4 on your diagram in the middle picture and locate M1. So imagine a pretend line being drawn from F4 to M1, and the sleep system is picking up the electrical activity between those 2 points. Any electrical activity that is the same is being discarded, and the electrical activity that is different at F4 than M1, that is what is being displayed on your screen. So we have 2 inputs, one being F4, the other one being M1, M1 being the reference, and anything that's the same between those 2 electrodes is being dumped out. Any electrical activity that is different is being recorded on the screen. For channel 4 on the same montage, the picture on your left, this is your C4, or your central lobe. Find it on your picture in the middle. Draw an imaginary line over to your M1. And again, they're comparing the electrical activity between C4 and M1. Anything that is the same is being dumped out. Anything that is different at C4 is going to be displayed on our screen. Channel 5, we're doing this with O2. Find O2. Draw an imaginary line to M1. And again, all the electrical activity between those 2 points is being recorded and compared. Anything that's the same is being dumped out. And anything that is new is being recorded. This is why it's called a referential system. We're all referencing the electrodes that we want information from is being referenced to a common reference electrode. Now, I want to mention something about your system reference electrode, which is in the yellow triangle, and it is your electrode site labeled FZ. Notice we don't see that anywhere on our montage setting. This is our system reference. And what that means is even though on our screen we can only see channels 1 through 15, the computer is still gathering all the data from all the other electrode sites that we have an electrode hooked up to, because those sites are being referenced to FZ in the computer's memory system somewhere. So when we go back and play this study later and we score it, if I'm looking at my channel 3, where my frontal lobe is, and I want to see my F3 for some reason, maybe the lead goes bad or whatever, I can change that channel to F3 to M2. And the computer already has that data, and it's because we use the FZ electrode, and inside the computer, nowhere that we set up, that's just automatically doing it, the computer has all the electrodes referenced to the FZ electrode. So in computerized sleep systems, we have to have a system reference, and that is our FZ electrode. Some sleep centers may use a different electrode for that, but it's pretty standard that people use FZ. Back on the old paper machines, we didn't need a system reference because we could only capture the data that was actually being recorded on our paper machine at the time. So computerized systems allow us to gather data from all the electrode sites because of this system reference electrode, or FZ, which paper systems didn't have. Okay, one other thing, our CZ electrode, also in a yellow triangle, that is our ground electrode, and that's your electrical safety ground is what that's referring to. Let's go on to our next slide. Okay, on one of our previous slides, I had talked about our input 1 and our input 2. And I want to come back to that now. So here we have a picture of our patient, and we have exploring electrode coming off the top of their head, at the electrode site of C4. That's our central lobe. Then you see your reference electrode, your mastoid 1 there behind the left ear. So the C4 electrode is considered our input G1, or our exploring electrode. Our input G2 is considered to be our reference electrode, which is our mastoid 1 on the left side, because we always want to go across the head anytime we can. Those two electrodes are plugged into our head box, and I'm going to show you a picture of a head box here in a little bit, but for now just know that that's plugged into our head box. And again, some head boxes include the amplifier and other converters that we don't need to worry about at this point. That information is then taken to our sleep system and gathered and portrayed on our computer screen, and I showed you what an epoch looks like now. So all the data from the patient is being presented to us, and we're telling the computer through our montage, we're going to set up what's called our montage, and that's what determines what is going to be in each channel of our sleep system. The example we looked at before, the right eye and left eye were the top two channels. Now in some sleep labs, they like to put the eyes right by the chin rather than at the top of the screen. So again, that's going to be a difference in sleep centers, and you'll adapt to that. That'll be fine. But for now, I just want to we're going to take a step back and look at these inputs G1 and inputs G2, and how that exploring electrode and that reference electrode, how those work together for us to get the EEG signal on the screen. So let's go on to our next slide. So from the previous picture, considering our input G1 is C4, and let's say that our input G2 is also C4, and this is going to be your top diagram in front of you on the left-hand column. So if our input for G1 and our input for G2 were the exact same electrode, C4, then if you look to the right, the output would be a flat line. The reason for this is, remember how I told you that it compares the two electrodes, and anything that's the same is tossed out, anything that is different is then pictured. So since these two are exactly the same, they cancel each other out. There is no voltage change shown because they cancel each other out, so you get a flat line. So let's go down to the next two input G1 and input G2 with the purple writing beside it. So if our input for G1 is C4 and our input for G2 is M1, notice the input 1 has a voltage, it has a triangle going up, and G2 is just a flat line. Now look what its output is going to be. So everything that's the same between the two is going to be canceled out, but we're going to see that deflection, that negative deflection. Negative means it goes up above baseline, exactly like that of C4. So you can see the C4 electrical signal is the result because that is what's different when it is compared to the reference signal. Okay, let's try another one down where the green typing is. So if input 1 is C4, and you see that that has a negative deflection, meaning it is going above baseline, and you see the M1 deflection in input G2, and you see it has a positive deflection, meaning it's going below baseline. Now look at our output. Since the signals are opposite of each other, the difference of those two are amplified. Notice the output on this side, the triangle, is larger than either of the two inputs on the input side. So your output triangle is twice the size of input G1 and input G2. Now we could do this in mathematical terms, and we had this on one of our assignments for last week, where it was you have a C4 of -50, and you're going to reference it to -100. What would your output be? And your output would be -150. That's the same thing that we're doing here. We're just not using numbers. We're just representing it with a picture. Okay, so the output of the signal is going to be whatever is different between the exploring electrode and the referential electrode. Anything that's the same will be rejected, and anything that is different is going to be amplified. Let's go on to our next slide. So here is an actual picture of EEG inputs and how they're going to be represented based on what we just learned. So in the top picture you see your C4, and that's the electrical activity coming from the central lobe on the right side of the brain, and that's input G1, or also known as our exploring electrode. That is being referenced to M1, and it shows you an example of what M1 looks like all by itself. Now when it's put together, you see it's highlighted in green. That's what you would see. See how it looks mostly like the C4, because that is what is different between those two. So that is what a referential montage is, and that's the type of setting we always use for sleep. We always use a referential recording. Now in the bottom left hand of your screen, this is an example of that bipolar montage, and we do not use this one, but see how they're using an exploring electrode for both the input G1 and input G2, which we didn't really know the difference between them before, but now you know the frontal right lobe is an exploring. We want to find out about that lobe. We want data on that, so that would be an exploring electrode. And when you compare that to C4, those two are very close to each other. They're going to have very similar electrical activity. So when you compare them to each other, look at your result. See how you lost the important information because it canceled out everything that's the same. So we always want to take the lobe or the area of the brain that we're trying to learn about, and we want to compare it to a reference. And the references that we choose, the M1 and M2, are on the mastoid process. They're right behind the ears, and in that area of the head there's very, 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 very little EEG activity. So if we compare C4 to M1, our exploring electrode, to our reference electrode, since our reference electrode has such very little activity, that enhances the C4 electrical activity, so we can really get a good view of what's happening in the central lobe of the right side of the brain. Okay, let's go on to our next slide. Okay, so here's a picture of our head box. So once you get your patient all hooked up, you're going to plug your electrodes into a head box, and it could be a head box similar to this. It could also be a head box that looks totally different. Every computer system has a different type of head box, so you have to just adapt to your environment. But I do want to point a couple of things out. Circled in blue at the bottom of this head box, this system has a poly ground site for you to use. On the head box I always used, we always put it in the CZ location on the head box no matter what. That's how our system was set up. So wherever you go to do your clinicals, that's something you're going to want to check with your site, is which electrode sites do you use on your head box for their correlating electrodes. Now if you'll find the purple circle, is just above that there, that is your reference site, and some people would use that instead of using your FZ. Again, I always use CZ as my ground and FZ as my system reference electrode. Now you see on this electrode, or on this head box, they don't have an M1 and an M2. Circled in green, I have for you A1 and A2, because M1 and M2 is more current terminology. Historically, those were referred to as A1 and A2, and the A stood for auditory because it was behind the ears. M1 and M2 make much more sense, but just so you know, you may see those interchangeable terms. A1 is the same as M1, A2 is the same as M2. Next, you see I have circled in red some polarity ones where I have 1, 2, 3, and 4, and they're matched up together, so you can plug 2 electrodes in at number 1, 2 electrodes in at number 2, 2 electrodes in at number 3, and 2 electrodes in at number 4. This is where you're going to be putting any of your EMG electrodes. Also, this is typically where you need to put your thoracic and abdominal belts. And you maybe even need to put your thermistor in this one as well. Again, that's going to depend on your system that you work with. Oh, and EKG would go in this one as well. So again, that's going to depend on the system you work with. Okay, let's go on to our next slide. Okay, so looking at this epic now, this sleep study, can you identify what each channel is recording? For example, what part of the brain is being recorded on each channel? Or is a channel recording an eye? Or is a channel recording a chin? That's where you should be heading to. You should be able to look at this with the montage setting there in front of you, and you should know what channel that is. Or if you see R-EOG, you should know that's the right eye recording. Or if you see O2 to M1, you should know, oh, that's recording the information on the right side in the occipital lobe. Okay? Where we're going to be heading to in our upcoming weeks is identifying all the settings that we need to have these channels run like this. There's different filters and sensitivities, and we're going to delve into that in a few weeks here. For now, just be able to identify what each channel is recording, know what your exploring electrode is, and what your reference electrode is. Let's go on to our next slide. This is just reviewing again that these settings here to your left is an example of a referential montage. We use the reference electrodes M1 and M2, and in order for the computer to also record the data from C3 to M2, F3 to M2, and O1 to M2, we must use a system reference electrode, which we talked about already is FZ, and then our ground electrode is CZ, and that's for our electrical safety. Let's go on to our next slide. Now I want to take a look at understanding our eye electrodes. In one of our first few chapters or sections that we read about, it talked a bit about polarity, and that is always a very confusing topic for everybody. And really what you need to understand the polarity about is when we talk about the eye electrodes. If you look at the epic in front of you, the top 2 channels are your eyes. And if you move to about the 13 to 14 second mark and so on, you see those eye leads are moving all over the place. This is an epic of stage R, which is otherwise known as stage REM. This is your lightest stage of sleep. This is your dreaming sleep. This is when your brain is highly active, but your muscles are paralyzed. Your chin is very quiet right now, and you see your eye movements moving around in the head very rapidly. So let's take a look at what that means and how the system does this. Let's go to the next slide. Okay, so I have a couple of pictures here for you. Now, I used this book called A Technologist's Guide to Performing Sleep Studies, and I really like how they explain the eye channels. They explain it as that the eyes are like a battery, and that one side of the eye is positive and the other side is negative. So you see the retina is negative in the picture below, and the cornea is positive. So when we record the eye movements, also known as the EOG, on a polysomnogram, if the eyes are open and looking straight ahead, the EOG channel recording is a fairly straight line. There's some bumps in it, but it's fairly straight. Anytime the cornea and the retina move, we will see movements in the EOG channel recording. For example, if you take a look at your picture on the right, in the middle of that recording there, you have where the eyes are looking ahead, and to the left and right of that, you see the eyes looking left and right. So the red line in the text box there is showing you what the recording looks like when the eyes are looking straight ahead. Now let's assume we have the left eye in channel 1 and the right eye in channel 2. That's what is pictured in front of you, which this is slightly different than what our other tracing looks like. But in this example, the left eye is on top and the right eye is on bottom. When we ask the patient to look left, pictured in front of you, the cornea of the left eye will move closer to the left EOG electrode. This makes the output of the electrode, or what we see on our EOG channel, more positive, meaning that it's going to deflect downward. A positive deflection means it goes downward. When we say positive in EEG, this means our pens actually move down on the tracing or on the paper. So as the positive part of the eye, again the cornea, moves towards the electrode, we're going to see the downward deflection on our tracing. At the same time, the eye's retina is moving closer to the right EOG electrode. This makes the output of the electrode, or what we see in our channel, more negative. When we say negative in EEG or in our sleep recording, this means our pens are actually moving upwards and making an upward deflection. So as the negative part of the eye, the retina, moves towards the electrode, we see an upward deflection. Okay, I'm going to pause right here and tell you something one more time. A negative deflection means on the paper it's moving upward. A positive deflection means on your paper it is moving downward. So in front of you on your picture, starting at the left, you see E1-M2, that's your left eye, and those eyeballs are looking to the left. So your cornea is moving towards your electrode. This is making a positive deflection. See the plus mark on your tracing? And see how the line dipped down. Okay, now keep staying on that top line and let's go over to the next one. Now the person is looking right. So now the retina is moved away, or the retina has moved towards the left eye electrode, excuse me. So that has made a negative deflection, and now that line has moved upward. And then it goes back to center. So if we look down at E2 to M1, and if we follow that line, on the right eyelid, the retina first comes close to the right eye electrode, causing a negative deflection, meaning the line is drawn upwards. Then you see it look straight ahead again, and then then the patient looks to the other side, and the cornea of the right eye becomes closer to the right eye electrode, so you see a positive deflection, and the line moves downward. Okay? I know it's confusing, so you might want to write that down. A negative deflection, the line moves up. A positive deflection, the line moves down. Okay, let's go on to our next slide. So here's an example.